Today's lesson is called Operations with Functions. For the opening exercise, when a function can be written as an equation, the symbol f of x replaces the y and is read as the value of f at x, or simply f of x. Okay, so if I were going to demonstrate that, what we're trying to say, and you do not need to write this, I'm just showing you, is that g of x, this entire thing, is coming from y. It just means the same thing. So instead of writing y equals, we're writing g of x equals. Keep that in mind. So what I would like you to do is evaluate the following expressions given the functions below. Pause the video and resume when you're ready to go over the answers. Okay, in part B it says g of 10. So I'm going to look up and use my g of x function. -3 in x's place will go a 10. So that's -30 plus 1, which means g of 10 is equal to -29. In part B, it says h of -2. So we want to make sure we pick the function that's appropriate. We're going to use h of x, which is 12 over x. So this is going to be 12 over -2. So h of -2 would be equal to -6. In part C, g of -2. I'm again going to go back to my g of x function, which was -3x plus 1. I'm going to put -2 in x's spot. So g of -2 is 6 plus 1, which means g of -2 is equal to 7. For f of 3, I'm going to look at my function f of x. They would like me to use x squared plus 7. So the 3 goes in x's spot and the squared is on the outside, plus 7. So f of 3 is equal to 9 plus 7, which means f of 3 is equal to 16. In E, h of a, I'm going to go to the top and use my h function. H of x equals 12 over x. So that's 12 over a, and that's it. That is my answer. There's nothing to simplify. In part F, it says g of b plus c. So we're going to use our g function, which is -3x plus 1. But we're going to replace the x with b plus c. So this would look like this: -3, then b plus c, and then plus 1. So we would have to distribute this -3 through the parentheses, and I would get g of b plus c equals -3b minus 3c and plus 1. I would look at that to see if there's any way I can simplify it, but I cannot. So this is my final answer. So let's move on to our examples now together. Example 1, sometimes it may be necessary to find the input x value of a function given the output. So going back to what we just did in our opening exercise, put a little note here that we were given the input and we were finding the output. Okay, that is different than what they're asking us to do in example 1. Here, they're going to give us the output. We need to find the input. So using the functions from the opening exercise, find x if. Okay, so I'm going to put a little note up here that this means we need to solve for x. We're finding the input this time, not the output. So in part A, we are going to replace g of x with the actual function from above. G of x was -3x plus 1. So -3x plus 1 equals 16. Now we can actually solve for x. We would subtract 1 from both sides and get -3x equals 15. I would divide both sides by -3 and get that x is -5. So now I know my input, or my x value, was a -5. It was put into the g of x function, and 16 was the output. In B, h of x equals -2. H of x, if we go back up and take a look, was 12 over x. So now I know that -2 is going to equal 12 over x. This I can make a proportion by putting negative 2 over 1 and cross multiplying to see that negative 2x equals 12. And then divide both sides by negative 2, which gives me x equals negative 6. So my input would have been negative 6. F of x equals 23. If we go up here and take a look at f of x, it's x squared plus 7. So 23 is equal to x squared plus 7. And notice what I'm doing. I'm showing you that it doesn't matter which way you write it. You can put the variables on the left and number on the right or vice versa. So now we're going to solve this. First, we're going to move 7 by subtracting it from both sides. That's going to give us 16 equals x squared, and now chapter 1 is coming back. If I want to undo squaring something, I must take the square root. So I'm going to take the square root of both sides, and I get that x equals, now remember, if we're taking the square root of 16, that is a positive and a negative 4. 4 times 4 is 16, but also negative 4 times negative 4 is 16. So my input must have been positive and negative 4. Now, a couple of reminders. These are important. I would star these, highlight them, whatever you need to do so that you know how important they are and refer back to them. F of negative 3. That's how you read that. F of negative 3 means that negative 3 is your input, and you are going to plug it into the given variable in order to find the output. On the other hand, f of x equals negative 3 means that your whole function is equal to negative 3. That's important. And you replace the entire f of x with that negative 3. So here you are finding the input. This notation is so very important to know the difference between. Now going on to example 2. Example 2 says, just like you can add, subtract, multiply, or divide numbers, you can do those same operations with functions. So suppose you have two functions, f of x equals 2x squared minus 3x plus 4, and g of x equals x plus 3. We are going to find the following. So in number 1, they want us to find f plus g of x. So that's telling us they want us to take our two functions and add them together because of this plus sign right here. So that would be 2x squared minus 3x plus 4. We're going to add to that x plus 3. So now this should also be taking you back to when we worked on all of our polynomial operations. We have like terms that we're going to have to combine. So I see like terms of negative 3x and x. Everything else is different than that. We don't have anything to go with the 2x squareds, but we do have 4 and 3 that count as like terms. So that means my final answer is 2x squared. My x's give me negative 2x, and 4 plus 3 makes 7. So there is f plus g of x. In number 2, f minus g of x. So here they want us to subtract them. This one, put a star next to, because the way you set this up, you have to be very careful. We're going to put the f function first because that's what comes first in the parentheses. So that was 2x squared minus 3x plus 4. We need to subtract g of x. But g of x, if you go back up here, is a binomial. We have to subtract that entire quantity. So we're going to put minus, but then in parentheses, we're going to put x plus 3. This tells me I have to do a bit of leave, change. So I still have 2x squared minus 3x plus 4, but then I'm going to change the subtraction to addition and make all of the signs in the second polynomial the opposite, negative x and minus 3. Then I can find my like terms. I've got x squareds there, x here, and then positive 4 and negative 3. So my expression would then be 2x squared, negative 3x minus x would be negative 4x, and 4 take away 3 would be plus 1. So you can see the change in doing that subtraction. Also, remember I'm writing things in descending order, which is your standard form for a polynomial. In number 3, the dot implies multiplication. So here, they would like us to multiply the function of f times the function of g. So this is going to be 2x squared minus 3x plus 4 in a set of parentheses multiplied by x plus 3 in a set of parentheses. Now recall your options here for how to multiply these. You're going to use either distributive property or you can use the area or box method there to set up the area model and do your multiplications. I'm going to choose to do distributive property. So first I'm going to take the x all the way through these parentheses and get 2x cubed minus 3x squared, then plus 4x. Next, I will take my my positive 3 through the parentheses and get plus 6x squared minus 9x and plus 12. Now I will find my like terms. I see 2x cubed, but I don't see any other x cubes. I have minus 3x squared and plus 6x squared. I have a 4x and a negative 9x. And then I have a number down here that I will box in that has no other like terms. So when I simplify this, I get 2x cubed. When I combine my x squareds, I get plus 3x squared. 4x and negative 9x would make negative 5x. And then I have my plus 12. Now underneath, it says note. Adding, subtracting, and multiplying functions may also be denoted like this instead. So the ones on the left are the ones that we just saw when we did our examples up top. The ones on the right are the alternative ways of writing it. So they could write f of x separately, then the plus sign, then g of x, and similarly for subtraction and multiplication. So for number 4, it says find f plus g of negative 3. So now, instead of just having the simplification of the polynomials, we're going to have to do the simplification of the polynomials or use the one that's already been done and actually evaluate it at negative 3 and at 1/2. Now, f plus g, we already found up here. F plus g turned out to be 2x squared minus 2x plus 7. So since I've already done that, I'm going to come down here and just do my substitutions. I have 2 times negative 3 squared, and we have talked several times about the importance of having that negative 3 in parentheses when you substitute, minus 2 times negative 3, and then plus 7. So as a quick note, so you remember later what we did, we're going to sub in negative 3 for x, but going back to number 1 up above. Okay, so this becomes 2, because think of order of operations. Parentheses, exponents. Exponents come before multiplication, so we're not going to do the 2 times negative 3. We're going to do the negative 3 squared first. Negative 3 times negative 3 would be a positive 9. So 2 times 9 ends up being 18. Then we have plus 6 and plus 7 for a total of 31. For f times g of 1/2, if you recall, we're going to go back and use what f times g was. So that was 2x cubed plus 3x squared minus 5x plus 12, but we're going to put 1/2 in all of the x's positions. So for here, we're going to use the f times g, which if you recall, when we go back up, is the 2x cubed plus 3x squared minus 5x plus 12. We're going to use that, but we're going to put the 1/2 in all of the x's positions. So we've got 2 times 1/2, which is going to be cubed, plus 3 times 1/2, which is going to be squared, minus 5 times 1/2, and then plus 12. For this one, we're going to jump right to the answer because I do want to show you that this minimally is the amount of work I would need to see. As long as you show me your substitution step like you see for number 5, you can use your calculator to calculate the rest. So I would pause the video and see if you can get the value on your own on your calculator. Remember to type it exactly as you see it, parentheses included. Then resume the video to make sure you have your proper answer. Okay, you should end up with 10.5. And that concludes our lesson on operations with functions.